Flux to help soldering. Good morning everyone and welcome to my live event. I don't know if you can hear me well. If you can hear me well, please can you say something? Right, we are hearing you. Thanks very much for that. So today putting a different tip, very thin one. It's turning on some paste. Good morning everyone again. Is my audio, is the audio good? Can you please say if the audio is good? Yes. Today it will be in English, okay, because I know that I have a lot of friends that do not understand my native language, so I decided to do it in English. And so in English everyone will understand. Okay. Just got some new PCBs on the mail yesterday. And these PCBs will hold the radio module that I will adapt to a bigger board. I will show you the bigger board in a minute. I'm just unpacking all the stuff. I need to solder at least 5 of these Wii boards. One, two, three, 4, 5. Okay. It's all done here. more flux, and we need thin soldering wire. Okay. Okay, so let's get the other boards so I can show you what I'm doing and what for. This is the big base station board. It's has a few hanging wires, but that's natural. When you are developing the code, sometimes you realize that some bits of the hardware need to be changed, so you have lodging wires. And okay, so the big base, it's a base station for a LoRa. For those that you don't know what LoRa means, it's long range radios, very low power but long range. These base stations will be put on top of the mountains, hills, on top of big buildings. They will receive signals from long distance wireless nodes. And hello everyone that's coming in. Pedro Martins, Luis Lapa, André Cartacho. We have other people there. There's someone with a Greek name that I don't know how to pronounce, I'm sorry. Mario is there, David also. So I was saying, these base stations will be put in very high places outside. Has a radio module. This small board will attach here. I'll show you later when everything is finished. There's a GSM GPRS modem here, SD card for logging, mains connection area with all the protection and gas discharge tube, varistors, power supply. There's an LCD screen. There's a rotary encoder, USB connection. There's also a connector for wind speed sensor. Okay, so if the wind is too strong in that area, the base station will send a message to the server or to the people taking care of it, and they will go there to do whatever is necessary. Battery connection, battery charging, solar panel connecting here. It's a complete base station. This is version 1, version 2. Version 2 is already being prototyped. It will have a powerful processor. The processor here is a, probably you can't see, it's a EFM32. It's a Silicon Labs Gecko. It's an ARM Cortex. It's a ARM Cortex M4 with DSP instructions inside. And the next generation will have the same processor here, but it will have one more CPU, an ARM Cortex A5 or A8 that will mainly run Linux, embedded Linux, so we can have extra processing power and other stuff being done in real time, because in most situations we need processing and to be done locally and then send small pieces of information to the server, instead of sending everything to the server and taking a lot of bandwidth by the GSM GPRS or other modems that we will have, maybe an Iridium connection for satellites. We'll see. But for now, I'm doing these small boards that will attach here, and that's what I'm going to concentrate today. Hello Pedro from Madeira Island. Very, very nice island. Thanks, David. And Ruben. Good morning, Ruben, and welcome. Okay, so I will need modems for this. Let's see. I will need modems, I will need capacitors, and I will need the schematic to remember myself. What do I have here? Okay, let's see. Alright, so capacitors, power filters, radio modules. I need to open this. I'm using I'm using the microchip module because it was the fastest way to prototype the idea. Okay, the microchip module, I'll show you, comes in these trays. But before doing this, I need to protect myself from discharge. If you guys don't do it, you should do it working in your private lab at home or wherever you do it. You need to protect yourselves. Not yourselves, more the equipment, because if you are working with electronics, you should protect the electronics. Protects you from problems later. Okay. I will attach this to my wrist. Okay. Alright, so what do you need more? More LEDs, resistors, etc. I have a few of those. Okay, and I need also an SMA connector for the antenna. Something like this. I'm going to use 868 megahertz, 868 megahertz. So I only need one of the connections. The board has two connectors, as you can see on the top. But I'm using only one. So I have the possibility of going 434 megahertz if I want. But for now, the experiments will be on 868 because that's what we've been doing, and that's the frequency we need to use. Okay. Let's get more components. Let me show you how the radio modules look like. So just a few, not many. The final production, if I decide to go with the module, the final production will be a few hundreds. If I decide to go with the chip only, that's just inside the module, still the same quantities. Okay, put it inside, take it out when needed only. I'm not going to need it yet, just gathering all the components I need first so everything is faster. I think I have everything I need here. Not this one. Uh, 2.20. Yeah, I have everything I need here. So LEDs. Okay, almost everything, but still the most important bits I have, so I can do the thing. That's what I needed. Some LEDs. I don't know the color of these. Sorry guys, it's just when you're preparing a production, this is not a production, it's just a very small prototype run, but you need to make sure that you have everything. And some of the bits I don't normally use, so okay, I think I have. Let's put this out of the way for a while and let's prepare the boards. I'm going to the most tricky bit is soldering the radio module, so I'm going to I'm going to tin the pads where the module will be, so it gets easier to solder later. Okay, I'm going to put a bit of flux because flux is good and you want flux. The PCB is gold plated, but still I always like to put a bit of flux because it will clean and it will solder much better. Okay, it's much better for you guys, believe me, when soldering. Alright, let's do it. When you're doing this, you don't need to put much solder, okay? It's just a bit, just a tiny bit, in order to thin the pad. You don't want to put too much, because if you put too much, then it will be difficult to solder. There's too much in it. Yeah, that's it. I don't know if I can show you. It's difficult with this camera. Sorry guys, but putting just tiny bits. The pads that resist the heat are the ones connected to the ground. That's usual. It's a bit more tiresome, but you need good ground, so don't give up. Good ground is very important in radio electronics, analog electronics. It's important in every electronics, but for radio, if you don't have a good ground, your circuit doesn't work, doesn't perform as you wanted it to perform. So let's see, we have more people coming in. Mrs. Sulmira, hello, it's been a while since we don't talk. Hope everything is right. Flavio, how are you, Flavio? Great musician, Flavio. Go and see his work, please. Hello, Marco. Marco Oliveira, how are you? Hope everything is good. And I have a question for everyone listening to the transmission. Have you guys worked with the ones that have worked with radio? Which technologies did you use, and did you like it? Just give me your ideas, please. I'll just always like to know, because I decided to move my radio modules for LoRa instead of other technology, because LoRa it's the same, you use the same or lower power for all the transmissions you need to do. Transmissions are receiving, let's say service, for all the service you need to do, and you have very long range. And when I say long range, is that you can have kilometers with a small antenna, and a very small radio. So that's a plus for me, because the service I've been doing with these thingies you need very small stuff. So Flavio, thank you very much. thank you very much. We should get together on Skype one of these days. Okay, catch up a bit. I have a few interesting things to say, and I'm sure you have a few others to tell me. A wireless for the guitar. Yes, well, the wireless for the guitar, you need high bandwidth. If you do it digitally, it's better to do it in 2.4 gigahertz because you need high bandwidth to transmit the audio signal from the guitar. And if you did analog, well, it's analog. You have plenty of circuits and transmitters already in the market. Digital too in 2.4 because I've seen. But there's Tone Control Labs. It's the brand I've created. The company I've created is releasing something like this in terms of wireless audio. So just hang on over there. I don't know when, but it's close. It's closer than ever. So let's take one module off. I can do this by hand. I can touch these things like with my bare fingers because I'm protected. Okay, I'm connected to Earth. So needn't to worry if you are protected. So align your module conveniently. If you need to put more flux, put more flux. Flux is to be used. Flux is never too much. Okay, or alright, let's see, always never too much. Alright, so when you have your module aligned, when you do this in a factory, everything is automated and it's no issues at all. The machine does everything for you. But when you do this in your private lab or in the office lab, you need to be very careful to align everything precisely, because if you don't, poof. Alright, that's it. It's not completely soldered. I just soldered 2 pads on one either side, enough to hold the module. So as you can see, I can now solder everything with no issues now. Alright, so good thing that I've tinned the other bits first, so I can now go and continue the process. I'll put a bit more flux, just a bit, not much. Just a bit. Need to get another flux. This flux is not the best for this. Not the best for this work. It's something more liquid. It's good for other purposes, but you can use the pens, flux in a pen, if you want. It's like a marker. You can use something like this, but it has too much alcohol, and when you put the iron, it just evaporates very, very fast, and the flux disappears. So depending on what you do, again, you use it differently. Okay, so let's do it. the ground pins again. Oof. I need to change the tip of the iron to do the ground pins because there's too much copper mass and it's dissipating the heat and I can't get good temperature, so I'll solder the fine stuff all over the board, and when I'm going to the connectors I will just change the iron tip and do the rest. It's looking good. Let's do the other side. So we have here Fabio. Hello Fabio, thanks for watching. Hope everything is alright over there. Thanks everyone for hanging around and listening to my stuff. For those that just arrived, I am soldering small radio modules to a breakout board to be installed in a bigger system, a base station for radio reception. And these radios are LoRa technology, long range, low power. And I've decided for these prototypes to use the microchip modules because I know them, I've worked with them in the past, and I've also worked with the chipset that's inside by itself. And for now, for the application, I need using these already built and canned modules are faster. So I've soldered all the bits except the ground pins, because the ground pins need a lot of heat and I need to change to my bigger tip, and I'll do that when I'll go for the connectors. For now, the connectors for the antenna and the connectors for the headers. Okay. I'm going to do one. I'm going to show you a complete board and then I'll do the rest myself. Just to repeat, rinse and repeat, rinse and repeat. Again, it's never too much to say. If you want to do this stuff, do it, but always wear protection. Okay? Always wear electrostatic discharge protection so you don't zap your electronics, and it has happened to me in the past, things not working, and it was just plain and simple lack of protection and everything was fried by ESD. You don't want that, believe me. It's important that you protect the electronics so you don't have regrets later. It's easy. This is easy to use, so it's not painful. So do it. Okay, so let's put some heat. Let's tin the other components on the board so we can solder the resistors, capacitors, and LED and LEDs. For these you don't need them. There's no need for flux because the PCB is gold tinned, it's gold plated, so everything solders really well. Most of the components on this board are decouplings, power supply decouplings, because it's a very small board. it's mostly a breakout for the module itself. So what I've added here was decoupling. Good capacitors to decouple the power, a few resistors in series with the COM lines, with the COM bus, to protect both this board and the big system. If there's anything going on strange, the resistors will limit the current and everything is protected. So never too much to protect your electronics, don't forget that. So I've added some LEDs just for a situation when you need flux. I've added some LEDs to give an indication of what's happening in the board. It's good for debugging, not for the end use, because everything will be locked in a box, in a big box, in the tower, so no one will see this. But for debugging, very, very helpful. And since this is just a prototype version for the thing, we can solder by hand. There's no hassle. Okay, I think we have tinned everything. There's one here, another one. Okay, I'll leave the big capacitor for last too, because it has a lot of copper mass. Has a lot of copper mass too, so I'll leave this to the end. Okay, let's solder. Let's start with the resistors. Always, of course, you have your preferences, but start with the most difficult thing on the board. Normally, it's these modules like this, chips. When you have chips with no pins, you have to apply heat and it's difficult to solder. So start with those and test. If everything is good, now you can continue the board. So imagine if you have a big board like this, where you solder both sides of the components, everything is good. When you get to the end, you can't solder the chip and you make a mess on the PCB, you burn the PCB, and you lost hours soldering the first components just to burn the PCB with the last chip. So it's better to start with the most difficult one. If you're doing by hand, of course. If you're doing by hand. Okay, so resistors. Let's see what we need. Okay, 100 ohms. 100 ohms. I need 2 for now. Okay. If you guys can see this, it's very small. Sorry, I don't have a magnifier yet. Need to get a big camera for the PC so you guys can see what I'm doing on the board. So you get the resistor. The resistor is so small that the camera doesn't pick it up. 06, 03. It's good size for these things. You can go 04, 02 for doing things by hand, but if you want to do things by hand and you can afford it, the space on the PCB, go with the 06, 03, because it's much easier to solder than the smaller ones. The smaller ones will save you space, but you only need to save space if you're going to big manufacturers. If you're going to do things by hand, using a bigger package for the component, it's much better. Okay, let's apply a bit of this flux just for the final. Then you go with a iron again. Soldering will be great. That's it. If you want to have a good look on the PCB, because you don't have magnifying eyes, but you can get one of these. I got this from RS. You can get the code there, or you can ask me later in a private message. This is 3 times, 4.5, 6 or 9 times. I'm going to use the 4.5, I think. This is really good to see your work, because you can get down there with great detail. I just saw that I missed one of the solderings. It's a ground plane, okay, no worries. It's a ground. Looks good. I think there are 2 pins there that benefit if they get a bit more solder. So with these magnifiers you can get down to the board really fast. So sometimes, just looking at it you don't see it because it's so small, but that's it. Alright, good. So those 2 resistors are done. Such a small board, you solder it fast. So I need 0 ohm resistors. These 0 ohm resistors are in series with the antenna connector. I've added, I don't know if you can see, you get something to point. Here between the module and the antenna, I've added a few components. So if I need to tune let's say the module has an output of 50 ohm impedance, and my antenna is not 50 ohm, but I want to use that antenna, or I need to use that antenna. So where we can then, here I've put a few components there that you can tune the output. You can match the impedance of your radio to the antenna with these components. So now I don't need that, because the antenna I'm going to use, I know it's 50 ohm, but just in case, if you're doing prototypes, you just put it there. It's really easy. It's just 2 components. It's a couple of capacitors and resistor. That's so easy and so not expensive. So just use it. It's better to put it than in the future regret not to have put it. So believe me when I say that it's better to have something there. Okay, I just need one because I'm only going to use one of the antennas, so there's no need to go for both. So 868 megahertz. In case you wonder why this 868, it's called the ISM band. It's the industrial, scientific and medical bands, radio bands. It's free licensed. If you behave and you follow the rules, you can transmit, you can use that frequency spectrum with no license needed. But you need to behave. So behave, it's in terms of power, maximum power transmitted, and the frequency, I mean the period of your transmissions, the duty cycle. So it's a very good band, free to use, but you need to behave. So for these modules, for these applications, it's great because you get very good penetration in terms of radio waves, and you get low power, smaller antennas, because between 868 and 434, the 868 you have more penetration and you have half the size of the antennas, and you can have antennas designed on the PCB like a track or a very small ceramic patch. So benefits. Alright, so last resistors. I need one here and 3 over there. Okay, let's see. resistor? R4. Oh, there's another 100 ohms that I missed. No problem. Let's see. Cristiano, hello Cristiano, how are you? Marco again. Jorge. ¿Qué tal, Jorge? ¿Cómo vas? ¿Todo bien? You haven't speak for such a long time. Hope everything is alright over there. Jorge is in Mexico. Great friend from the university time, more than 12 years ago. Alright, so I'm putting so much attention on this board and these little details because it's a prototype and you want it to work flawlessly in your application while you are developing. Don't spare any time or any costs on your prototypes. Never, because prototypes are important. Okay. Hello Mariano, welcome. Thank you for your words. Thank you very much. Okay, so last resistors for the LEDs. For the LEDs, okay, we don't need too much power. There's no need for brightness, so 2 kilo ohm is more than enough. Let's see, we have 2 kilo ohms in our warehouse. 2.2, that will be alright if you use 2.2, that's not an issue. 1.5, I prefer to use 2.2 because less current wasted and the brightness is not important. I'm just looking for to light the LED. It's not important how bright it is. I just want to know that the LED is on and off. So 2.2 is enough. Okay. Hello Mariano. Solder flux, sometimes it depends. I've used solder flux for the soldering of the module. You weren't here before, but I've used it for the module. For these bits now, small resistors and capacitors I'm not using because it's faster this way. Hot air I'm not using because I'm not soldering any chips. It's faster if I use the soldering iron instead of the hot air. Don't ask me why. It's many years of doing this thing this way, and sometimes the hot air will get in the way. For chips is very good. For these very small resistor capacitors I prefer to use the iron. Okay, good. I think I'll just need capacitors now. Alright, caps. Picofarads, picofarad, 100 picofarads. I do have it, but it's 0805. It's too big. Yeah, that's it, Mariana. That's exactly it. Okay, so 100 picos I have, 0805. Too big. I can solder this tomorrow. It's not as important as the 100 nanofarads for power decoupling. How many do I need? 1, 2. Need 2. Okay. Just close the door. These are so small. Bit of flux with a pen. So I have, for decoupling purposes, I have 100 nano and 100 pico on every pin for power supply of the module. And sorry. And I'm putting the 100 nanos right now. First, and then I will put the 100 pico. It's when you have radio systems, or you know that you will have a lot of noise from high frequency sources. You should use this type of decoupling. Don't use only 100 nanos, or don't use only one capacitor on the power supply, because it will not be enough. Okay, the chips or the modules need to be decoupled right at their pins. The decoupling will filter the noise, and it will also provide extra energy, extra current peak. Sorry for my English. It will provide extra current availability for those very short peaks, very short demands. So capacitors are a tenth of a cent, of a pence, so use them. They're cheap and they don't take space, and you will be happy later because they are doing their job for you. Okay. Alright, I think we are done with the caps. I have a bigger filter cap with 4 pins. I don't know, you can see it. That's a special radio frequency EMI RFI filter. But this is big, I need a bigger tip on the iron, so I'll leave this to the end with the connectors and the big cap. I think I'm done here with. I don't have the 100 picofarad. Not that I know. Let me check my stock. Wait. No. I need to get some 100 picofarad to finish this, but for the first tests without radio transmission, it will be just fine. Probably even with radio transmission, it will work okay, but if you can, don't send a product out of the door without putting all the components you designed and all the caps that should be there. So for the first power on and talking with the main processor, this is enough. Okay, so resistors for the bus, resistors for the LEDs, 100 nanos for power decoupling, 0 ohm resistor for the antenna. I just need the big caps and the header connector, and solder the last pins on the module for the ground plane. I think I'm going to shut off the iron now, so the temperature goes down a bit. Ah, sorry, I don't know how to pronunciate your name. I think it's Greek. I'm sorry, I don't know. You've asked me a question there. You build pedal boards. Okay, good. Can we speak offline? Can you send me a message? Can we maybe make a Skype call later in the day? After I finish this, I can do that. All right. If you send me a private message with some details, we can go from there. Okay. Cheers. Thanks very much, and thanks for watching. Okay. It's always great to have people here. Thank you. It's SOT. Okay. Cheers. SOT. SOT. Okay. Yeah, it's from Greece. Thanks for watching. Yeah, I see the Sigma. Yeah, I'm not going to say it because I'm going to say it wrong. So thanks for being here. All right. So not yet. I used to have something to take the tip on with. I had a rubber. There's a rubber that comes with these soldering stations that when you can take the tips without turning off the iron, but that rubber, it's long gone for many years. Let's see. Don't do this at home, please. Okay. Sigma Omega TAF. That's it. Sigma Omega TAF. Hello, João. João, long time no see. I hope your princesses are alright. Say hi to everyone from me. Hello, Bruno. Again, one more time. Thanks for watching. Okay. Let's finish this while the iron is heating. Well, it's fast, but I'm gonna take the connectors I need. Big boxes. Right, let's see. What do we need? Okay. I was looking for this. Header connectors. I was lucky. The first one I got was exactly. I'm getting messages from another app that's stopping the transmission. I'm not sure, but okay. So I will save these for later because I will need more. I still need to build all these 5 boards, but for now I just want to show you how the okay, so let's start with the smaller capacitor, and I still have the pins for the chip to do. I'll put a bit more flux on those pins. They will need a lot of heat because it's ground pins, and you know, ground pins, so there's a lot of ground copper. just a bit. Don't put too much flux, especially if the flux is too thick. Just a bit goes a long way. If you get it wrong and you get too much, don't worry, you can still take it off and it will also evaporate and dissolve, so don't worry, there's always a salvation for that. Okay, thank you, Bruno, thank you very much. Let's have a first look before going on to the other ones. Looks good. Alright, let's continue. It's so easy. When you have a larger tip on the iron, well, you probably cannot see it with on the screen, but this is much larger, so there's a lot of heat in here. It's a difference from night and day. Everything goes, everything melts, everything goes really, really easy, so that's great. I only use this tip for this kind of work when you need a lot of heat. That doesn't happen every day. The majority of the things I do, it's small, so let's see. It's looking good. Who else is here? Hello, Nuno. Nuno Patricio, hello. Welcome. Thanks for joining. Okay, so next will be my smallish capacitors. Let's see if I can show you. It's a 4-pin cap. It's a 4-pin cap. It's a special capacitor for filtering high frequency noises, and it's very good for radio frequency boards, circuits, and also for if you want to design electronics to comply with the standards and you need to go to the EMC chamber to certify your product for radiation, for radio radiation. These are very good things to use when doing that, because it will filter the power supply, and there are capacitors like this for power supplies, and there are others for data lines, and for data lines these are very, very good. That's it. Job done. Let's have a look. Alright, so I'm making sure that with this cap at the entrance of the board, at the input, I'm making sure that noise from my main circuit, okay, doesn't go to my small board and to the radio, and also vice versa. The high frequency radio noise that may go into the power line doesn't go into my main board. That's important, because sometimes these high frequency disturbances can create havoc, create really great problems on your processors, and if you have analog to digital conversion, that just creates a mess. So last thing before the SMA connector and the headers is the big capacitor at the input. Big capacitor. I'm gonna tin both pins, because the majority of the capacitor pins are at the bottom, and it's easier to solder if you tin both and adjust heat. That's it. We are almost there. Now I'm gonna put the radio, the antenna connector. The antenna connector, it's something like this. It's an SMA connector for PCB, and that will just, that's it, goes like that. Let's solder the central pin, because there is no heat loss on that central pin, to make sure everything is good. Yeah, so when everything is good, you just go and solder the external pins that are the ground for the antenna, because those will take a lot of heat, so it's best to do everything at once. You don't need to solder all of them if you don't want. I am, because, well, this is a prototype and I want the best connection. I want the best electrical connection on my antenna. But you know, since the connector is made of metal, if you solder one, it will work. You have more for mechanical stability than for anything else. That's it. It's soldered. Good. Alright, so last but not least, I still need a LED. I'm not sure if I have this LED too, but I will look now before soldering the connector, because after soldering connector, the PCB gets a bit wobbly. You can't solder properly. Let's see. I have very small LEDs. 0402 is too small to use. need something bigger. Okay, alright. Just give me a moment, guys. My warehouse is just around the corner. I have a big pack full of LEDs. You know, I have time goes by and you collect a lot of components because you do a lot of work, and then for prototypes you just need a few, and it's cheaper to order 10 or 50 than just one. You end up collecting a few components down the road. That's it. All right, so this is red, high brightness. Good, that's what we want. Let me take one. Is enough for now. Okay, good. Again, for these components, this LED is very susceptible to electrostatic discharge, so please use protection always. I cannot stress that enough. Always use protection, and make sure that in your lab or office or wherever you're working, your equipment, your soldering iron is also connected to the ground. You may say that, well, that's obvious. Yes, but believe me, strange things have happened in the past. People not using protection or not knowing that the equipment was not protected. Alright, so let's see. This is so small that I can't see which side is anode and cathode, so it's better to use the multimeter. There we go. I don't know if you can see the light. Can you see the light? Maybe. Yeah, so that's the anode. If that is the anode. So okay, that's the anode. That's what I was looking for. One pin soldered, 2 pin soldered. Let's give a bit more heat to the other one, and it looks okay. LED is in place. We have the LED soldered. Okay. If you want to make sure, it depends on how your circuit is designed, but sometimes you can still, yeah, you can still make sure if your LED is operating, it wasn't burned with the soldering. Yeah, it still lights. It's very dim now because there's more components on the circuit, but yeah, we are good to go. So when I power this, I will have a LED to know that the power is on to the module, because I can't turn the power on and off from the main board. Okay, so now, as I don't have the 100 pico farad capacitors, I will add later, no worries, that's not a problem. I can solder my last thing, and that thing is the connector. It's bulky. Always leave the bulky stuff and for last. Connectors, big caps, connectors, so that you don't need to solder anything else. That's the last thing. Okay, so let's solder one pin to see if the connector is well placed. Okay, one. You will see. Okay, now so I have to correct. It's a bit misaligned. It's not aligned. So just press it. Give heat. Press it. release, and you're good to go. You can solder all the rest. Now that they are aligned, solder the opposite corner, and there you go. You can solder all of them. Okay guys, thanks for being here, thanks for watching. If you want to know more details about this board, please do so. Ask me, send me a message. We can talk on Facebook, or if you want video, we can do it in Skype. It's all good, no issues. Okay, good. That's it. Job done. I think I will pick up the phone and I'll show you with the other camera. The other camera is better than this one. Still doesn't focus. Well, everything is done as I wanted to show you. I'm going to do now the other boards that I have here. I need to finish everything this morning, because in the afternoon I will continue with the development. Thank you for watching, and thanks for the kind words. Hook me up with a private message, or just call me on Facebook. We can hook up on Facebook, or if you want, we can talk on Skype. Skype is good because it's voice and video. And before you go, check my Instagram account. Okay, Instagram account is I'm writing the handle here is _Sergio Sena. Hook me up on Instagram too. I always put a lot of stuff, pictures there, and I hope to meet you guys next time. Okay, thanks for watching. And my lab here, it looks small, but I have a lot of stuff packed in other places. But this is where I work some days of the week, and other days of the week I have an office in St. Andrews where I work with some more guys. I'll show you later. Cheers, thanks for watching, till next time.